Welcome to an example of finding the shortest path. The question before us asks us to find the shortest path from vertex A to vertex L and give your answer as a sequence of points. So is it A, B, E, F, I, L or something like that, or is it A, D, G, is it that way, or is it this way, or maybe it's this way, probably not, So what, from A to L, what's the shortest way to get there? These numbers that are on every line, these tell how far it is. So this would be like locations around the city and how many minutes it takes to get from location to location. So to get from A to B takes 26 minutes, maybe. And from B to E takes 25 minutes, etc. So we want to figure out what's the shortest route that we should take to get from A to L. That is the question, from A to L. From point A to point L, what's the shortest route, the shortest path? So this would be something like what Google Maps does when it figures out for us the shortest route between 2 points and guides us on that route. The people that program Google Maps, they think about things like this, and they figure out things like this. So we're just going to do a little bit of the math that's involved in figuring out the shortest path between 2 points. Now, I'm going to give you a whole algorithm right here. It's called Dijkstra's algorithm. But before I do, I've taught long enough till I know, I think, mostly how students think. And most students think the following way. They think, I don't need that fancy algorithm and it's confusing anyway. I'm just going to wing it on my own and figure out how to do it. I can do this. Start at A. Let me see. D, that way is 30 minutes, so it's better to go to B. This is a no-brainer. I'll just go to B. A to B. And in fact, let me just do it this way. I'm just going to go A to B. And then, okay, got that. And now it looks like E's shorter than going that way, right? And now what's the shortest? Oh, that 1 for sure. Go that way. And then the 3, we're moving towards the end here. Now it's 24, or I could go 11 and 2 is 13 and 18. I think it's 31. I think that's more. So that's not better. Just go straight in 24. So there it is. I don't need some fancy whatever. Well, my answer to that is maybe. That might be right. I think, in fact, that is actually the right answer. I don't know. We'll see in a minute to be sure. But I want you to know that I would not, on the exam, there's going to be probably 3 of these, and I wouldn't want to bet my grade on just kind of sort of guessing like that. I mean, it's smart guessing, but still it's not an official method. There's not a guarantee that's right. It might be right. You'll be right some of the time. You'll be wrong some of the time. So I just want to point out that that's not the official method. That's generally good thinking, but you're not sure, are you? My main problem with that is you're not. How do you know? You think, well, yeah, well, it's shorter. Well, how do you know it's not better to take a longer route at first, and then you can maybe do this 6 and this 2? Maybe that's shorter. Maybe you do a longer route at first because then there's shorter routes down the road, which mean overall it's a better trip. You see, it's more complex than that, isn't it? So that's why I'm going to give you a method down here, Dijkstra's method, that will for sure give you the right answer. And I just want to give you a warning, having taught this class many times, a lot of students don't have time, they don't want to give the time to learn the official method, and they kind of crank through the homework and they sort of guess, and they get it right sometimes, they get it wrong sometimes, they just redo it in the homework till it's right, and they think, oh, I kind of got it. Well, you're going to miss some of them on the exam. I just want to warn you up front. If you decide to go that way, then you will, because on the exam you only have 1 try for each of the probably 3 questions, right? So there's no redos. So you're going to miss some and you're going to be disappointed. So if you're willing to put in the time, I'll show you the real method which will guarantee that you get the right answer every time on the exam and you get these questions 100% correct if you care about that. All right, here it is. It's Dijkstra's method, Dijkstra's algorithm. Algorithm is just like a recipe. It's a series of steps, step 1, step 2, step 3, step 4, step 5, in order to make something work. That's all an algorithm is. We talk about algorithms a lot in math and science. It's just a way of making stuff. So this guy named Dijkstra, long time ago, came up with this algorithm, this steps that will guarantee that you'll get the shortest distance. That's what we want. We want to be for sure. So let me read it, and I know math definitions are crazy when you read them. Let me just read it once, and then I'll go back and try to make sense out of it for you. We'll actually do it. Okay, so what does it say? Mark the ending vertex with a distance of 0. Designate this vertex as current. So let's go do that. So that means we come in here, and we're going to say, okay, ending vertex right here, 0. You mark that one as 0. Because we're going from A to L, right? That's the question. From A to L. So we're ending at L. Mark it as 0. That's what he said. Mark the ending vertex with 0. And that vertex is current. Find all vertices leading... Let me change what I'm doing here. Find all vertices leading to the current vertex. Calculate their distances to the end. Okay. So it said, the rules said make this one current. I'll circle it. It's current. And think about all the points that lead to that point. That's the end, right? This is the end right here. What are all the points that lead to that point? Well, K leads to that, and I leads to that, don't they? They're the only 2 points that directly lead to the end, to L. And it says go back and calculate their distances to the end. Okay, so how far from K to the end? Well, 18. Right? Put an 18 there. And how far from I to the end? Well, whoops. That was a mistake there. Hit the wrong button. It's going to be 24, isn't it? So let me put that down here. That's a no-brainer, right? From I to the end is 24. From K to the end is 18. Good so far? Right? If you're at K and you're wanting to get to the end, you're 18 away. If you're at I and you're wanting to get to the end, you're 24 away. This is what we're going to do. We're going to be putting how far each point is from the end. That's Dijkstra's method. Come on down here. We did that. Since we already know the distance the current vertex is from the end, this will just require adding the most recent edge. Don't record this distance if it's larger. I'll get to that later. It'll make sense later. Let's go on to step 3. Mark the current vertex as visited. We will never look at this vertex again. So this one right here, I cross it out, meaning we're done with it. We've already thought about all the roads leading into it. That's what they mean by mark it as visited. Mark the vertex with the smallest distance as current and repeat from step 2. Go back to step 2. What do we mean? They mean find the smallest one. So we're looking at 24 and 18. Which of those is the smallest? Which one is closest to the end? Well, the 18. So that's our new current. Circle it. In fact, actually, let me just let me do this. Let me mark it like this. That vertex is current. That's the one I'm looking at right now. And so what do we do now? We look at all roads coming into that point, like this road and this road. Okay, and we find out how far they are from the end. Now remember, how far is K from the end? K is 18 from the end, right? Just boom, 18, right? Takes this 18-minute trip. He's 18 minutes from the destination. K is, that's what that means. He's 18 minutes from destination. Well, then how far is J from the end? 16 plus 18, huh? 16 plus 18, which is, what's that? 34, I think. 34. See what I did there? And how far is H from the end? Well, 2 and 18. 2 plus 18. In other words, he's 20, isn't he? Get rid of all this. He's 20. Do you see what I'm doing there? I'm finding out how far these points are from the end. That's what we're going to do throughout the whole map, is find out how far each point is from the end. So, and how did we do it? We just took the 18, because we knew k was 18 from the end, and we added the 2 to get the 20. Right? Because if k is 18 from the end, and h is 2 from k, then add 2, he's 20 from the end. And if j is 16 from k, take 16 and add 18, and you get j must be 34 from the end, right? Because it's 16 to here, and then 18 the rest of the way. All right, so you get the idea, I think, right? We're just adding up to find out how far every point is from the end. From the end. Okay, now, that whole time we were messing with this. That was our current vertex, right? This is the one we started with, then we did that one, crossed it off. We are done with that guy now. We're done looking at him. Next, how do you know when you're done with a vertex? We already looked at all the roads coming into that spot. When you look at all the roads coming into a point, and you add up their numbers here and here, then you're done. Then you cross off that point. He's no longer current. Okay, next we need to shift to next. Which one? You go to the next number that's closest. We got this number, and this number, this number, this number. Those three are available. Those other two are crossed off, aren't they? Where they're done. We've looked at them. So which one of these three that I've circled is lowest? Which one's lowest? Closest to the end? Well, the H in the middle there, right? Yeah. So let's grab that one. This one is now current. Now he's the one. And what does that mean when he's current? That means I'm going to look at all the roads coming into him. I'm going to say this 19's coming in. I'm going to take 20, add 19, 39. Why? What's got? Well, because H is 20 from the end, right? 218. He's 20 from the end. So if E is 19 from H, add 19, E must be 39 from the end. See how we're finding how far every point is from the end? Same thing here. If H is 20 from the end, right? 2 and 18, he's 20 from the end. Then G is 6 from H, so add 6 to that. G must be 26 from the end. You look at all roads. Right now H is current. I'm looking at all roads coming in. And how about this one? Can't I lead to H? Yeah, it could. Take the 20. Now, if H is 20 from the end, he is 2 and 18. He's 20 from the end. And I is 11 from H. Add 11, that'd be 31. But we already have a 24 for I. So I'm not going to replace it with 31 because 24 is lower. In other words, there's already a quicker route to the end, namely straight, right? We're not going to go from I this way, and that way. That'd be 31. That's further. It's better to just go straight 24. So you always keep the lowest number because you want the shortest route from that point to the end. Right? 31 is a different route from I to the end, from I to L. A long route where you go down, over, and back up, which takes 31, that's not better. We're going to stay with the 24. That's what it means down here when it says, if it is longer than the previously recorded distance, don't record it if it's longer. That's what Dijkstra's method meant there. So I'm not going to record the 31. Forget about the 31. We've already got a 24, which is lower. We're trying to get the lowest number, the lowest distance from every point to the end. All right. So we've already got all the roads coming in H. We're done with H. See, I've crossed off these three. They've been examined. I've handled every road coming into H, right? They're all looked at. Okay, next we have to find a new vertex to be current. So what are the options? 24, 39, 26, 34. All these are available. Which one's the lowest? The 24. I, up there at the top. That's the lowest number available. That's the closest point to the end. Go to that one next. So this one is going to be current. Now look at all the roads coming into I. I is 24 from the end. Clearly, just zip, there's the end, right? I is 24 from the end. So F is 3 minutes from I. So add 3. F must be 20. It's not a very good 27, is it? F must be 27 from the end. So there's one road coming into that point. Here's another road. Add 11. 24 plus 11 would be 35. But we've already got a 20. We already have another way that H can get to the end, which is quicker, namely the 2 and the 18, right? That's 20. That's better than the 35. H doesn't want to get to the end by going 11 and 24. That'd be 35. That's further, so we don't write the 35. We always just keep the lower number because we want the shortest distance from each point to the end. Okay, so we're done with I. See why I'm done? Because I've examined every road coming into I and added the numbers I could. All right, we need a new point. Let's look at what's available. All these are available. Which is the lowest number? I think it's G, that 26 at the bottom there. Right, that's lower than the 27, barely. So we'll go to G. G becomes current. And what do? We look at all roads coming into G. There's this one, and this one. Got to add up all of them. 26 plus 6 is 32, right? Yeah, 32. But this is already 20. Just keep the 20. There's a quicker way to get to the end. All right, 26 plus 17. What's that? 13, 43. But this is already 34. Forget it. Keep the 34. 26 plus 28. What's that? 14, 54. D doesn't have any numbers yet, so he takes the 54. So D must be 54 from the end. Why? Because G is 26 from the end, and D is 28 from that, from G. So add 28. D must be 54 from the end. All right. So now we're done with G. We've looked at all roads coming into G. So next we need a new current vertex. What do we got? 27, 39, 54, 34. Which one's lowest among the available points? The 27. We're up here, right? All right, so that one is current. Look at all roads coming into that one. All right, 27 add 3 be 30, but we've already got 24. So forget about that one. 27 add 1 is 28. Oh yeah, that's a lot better than 39. Cross out that 39. We're going to put 28 there. We found a better route from E to the end. We had an old route that was 39. I think it was going that way or something. Yeah, it was going that way. That was 39 from the end. But now we found a better way. E is only 1 minute away from F, and F is 27 minutes from the end. So that makes E only 28 minutes from the end, at least if he goes that way, right? So you write the new lower number. See how this is finding a better method? A better route as we go through. So that becomes 28. And then this one, 27, add 22. What's that? 49. So that puts C at a distance of 49 from the end because C is 22 from F and F is 27 from the end. So add those together. That puts C at 49 from the end. So we've done every route coming into F. Let me erase all this. And this will be 28 down here now. The new shorter route. Okay, and then we cross off F because we've done every route coming into F. Next, let's look for our available points. I know it's kind of long, tedious method, but it will guarantee, that's what's nice about it, it'll guarantee when you're done you have the best route. This is what Google Maps does real quick, something like this. All right, what's the lowest number among the available points? The 28, huh? There in the middle, E. All right, let's go there. We'll go to E. E becomes our current vertex. Now look at every road coming into E. That one, that one, that one, that one. There's a lot of roads coming into E. Add them up. 28 and 19. No, that's way more than 20. Forget about it. 28 and 1 would be 29. No, that's more than, so forget about it. 28 and 23, What's that? 51. Oh, yeah, that's better than 54. Yeah, so I'm going to cross this out and put 51 there. See what happened? E is 28 from the end, right? E right here is 28 from the end. And D is 23 from E, so add 23 and 28, 51. That puts D 51 from the end rather than his old way, which was 54 from the end. So we'll do that. And then the last one over here, add 28 with 25. What's that? 13, 53. So that puts B at 53 from the end. All right, we're getting close here. So this will be 51 down here now, right? 51 down here for D. D just got a better route to the end, a shorter route. And then we're done with E. We looked at every road coming into E. We're getting close. Hang in there, almost over. So which one of these is the lowest available point? Now we're way over here at J. The route will all come together at the end. Don't worry, it seems weird we're jumping way over to J now. But it'll come together, don't worry. Just keep following the method. You'll be good. That's what an algorithm is. Just like making cookies or something. You just got to do what it says, and some chemistry happens, and out come delicious cookies. So let's just keep following the steps. Dijkstra's method has been proven to work. So 34. 34, that's weird that we're jumping way over there to J. So let's go over there. That's the current vertex, J. Look at all roads coming into J, this one and this one. 34 add 16, no way, that's way higher than 18. Forget about it. 34 add 17, no way, that's way higher than 26. So forget about it. None of these roads are beneficial at all. J's done. We didn't make any changes. Move forward. Now we have this, this, and this. Which one's the lowest? Which is closest to the end? Looks like the C up top, 49. All right, go up there, make C your current vertex. Look at all roads into C. 49, add 22. It's going to be way higher than 27. Forget about it. 49, add 27. Oh, it's going to be way higher than 53. Forget about it. So nothing going on with C. Now, C can't improve anything. So cross out C. He's done. Look at what we have left. We have B and D. Those are the only two available. Which one's lower? Closer to the end? D. So go down to D, make this one current. Look at all roads coming into D. Boom, boom, and boom. 51 add 28. No way, that's crazy higher than 26. 51 add 23. That goes 28, no way. 51 add 30. There we go. There's 81, right? Because if D is 51 from the end and A is 30 from D, then 30 add 51, 81. That puts A at 81 from the end. If D is 51 from the end and A is 30 from that, then A is 81 from the end. So we've looked at every road coming into D. So we can get rid of that. That point is done. All right, we're almost there. We have to keep going. Even though we've reached A, we have to check everything. We have to cross them all off first. We're almost there. Which ones are available? Only these two, right? All right, which one's lower? B. Let's look at B. You got to go all the way till you've checked every vertex. B. B, look at every road coming into B. Well, I should have made him current. Look at every road coming into B. 53 add 27. No, that's way higher than 49. 53 add 25. No way. 53 add 26. I don't know. Maybe that's better. 79. Yeah. Yeah, look at that. That is better. See, good thing we checked this one. Yeah, so B is 53 from the end, right? That's what that 53 means. He's 53 from B to the end. The shortest route is 53. And A is 26 from B, so add 26, 79. That's going to be an improvement for A. A is now only 79 from the end if he goes through B, rather than the old way, which was 81 when he went through D. When he went that way, right? That's not as good a route. We got a new lower route. And that's it. Let's cross this off, and then we'll write down our answer. I'll show you how that works. So we finished B. That's done. Finally, we are at A. We are at A. Every vertex, they're all crossed off. We've looked at the whole thing. Now we're ready. I know that was tedious, but this is what it takes to guarantee the right answer. Let's map it out from here to the end. You ready? Now, how do you know which way to go? We're going to start at A. Do we go this way or do we go that way? From A. We're trying to get to L at the end, right? That's the end. This A is where we start, right? We're starting back here, and we're ending at L. We're going from A to L. So how do you know which way do you go? Check the numbers. They'll tell you, right? So A is what? 79 from the end. That's the shortest route from A to the end is 79. So if I go this route, if I go this way, subtract 30, right? If A is 79 from the end, and then you cover 30-minute trip to D, 79 minus 30 would leave 49 minutes, but that's not the number that D has. D has 51, so that can't be the route. Did you understand that? Let me go over that one more time. The real route, the true answer, the way we'll find it now that we've calculated everything, is it's the route that subtracts correctly. The route, let me write that down, route that subtracts. So the answer is the route that subtracts correctly. So it's the route, so the answer is the route that subtracts correctly. So what do I mean subtracts? Well, if A is 79 from the end, and you go 30 minutes to D, you should be 30 minutes closer. You should be only 49 minutes from the end by the time you get to D. But D says he's 51 minutes from the end. So that must not be the best route. That's not it. So then it's the other way? Yes, it is the other way. It's this way. Let's check the subtraction. If you're 79 minutes from the end, right? If A is 79 minutes from the end, and he takes a 26-minute trip to B, that will leave him 53 minutes from the end, which is exactly what B says. Yes, I'm 53 minutes from the end. So it's that way. Now from B, which way do we go? Do we go this way or do we go that way? Well, which one subtracts correctly? That's what we got to figure out. So let's see, 53 minus 20. So right, if B is 53 minutes from the end and you take this 27-minute trip, what's that going to be? Use your calculator there. What's that? 26 minutes. That would mean, no, C is 49 minutes from the end. That's not the right route. Must be the other one. Let's try the other one. B is 53 minutes from the end. You take this 25-minute trip to E. 53 minus 25 is 28. Yep, E is 28 minutes. That's right. That's the right route. This is getting messy. I'm going to try to get rid of all that mess, if you don't mind. All right, it's just still a lot of mess here. All right, so so the better route then is this way. It subtracts correctly. 53 minus 25 is 28. Now, which way from here? Do I go this way or that way? Well, 28, try the subtraction, right? The route that subtracts correctly. 28 minus 19, 2 put a 1, put a 1, that'd be 9. Nope. H is not 9. That's not it. 28 minus 1 is 27. Yep, 27. That's the right route. Okay, so let's get rid of this calculation then. There. So we're going that way. And now from here, we know it must be this way. And 27 minus 3 indeed is 24. That's right. And from here, 24 will clearly straight to the end because 24 is straight to 0, right? If you're 24 from the end and you take a 24-minute trip, boom, you're at the end. So there is the best path. Now that might have been, I think that was the path we guessed at first. You see, we were lucky, but this guarantees, if you want to just try for lucky on the test, you'll get it sometimes, other times you won't. But if you can follow this method, this Dijkstra's method, you will for sure get the questions right. These 3 of these probably on the exam, you'll get them right. Sometimes you get right by guessing, but this is for sure right. It's 79 minutes from the end. This is the shortest route from A to L. How do they want me to write the answer? Start at A and then B, and then E, and then F, and then J. That is a J, isn't it? Oh, I. Good thing I looked. It's I. And then L. There it is. There's the shortest route. A, B, E. Wait, did I forget the F? I'm being so dumb here. Let's try this again. A, monkey. I gotta put that back. All right. A, B, E, right? I'm struggling. A, B, E, F, I. A, B, E, F, I, L. There we go. There is the right answer to this question. And it's a total trip of 79 minutes. It's the shortest route to get from A to L.